Okay, so today we're going to be talking about solving multi-step equations. This is Chapter 1, Section 2. Inverse operations are operations that undo the original equation or operation. They are the ones that get rid of something to move it to the other side. So the opposite of addition is subtraction. The opposite of multiplication is division. The mean is another word for the average. Average is where you add up all the numbers that you have and divide by how many numbers there are. So, solving multi-step equations. In Chapter 1, Section 1, we talked about solving a single-step equation. Now we're looking at how to solve multi-step equations. So to solve a multi-step equation, we're going to simplify each side of the equation. Then we're going to use the inverse operations to isolate the variable. So a thing you want to make sure that you're drawing your attention to is that you always want to undo addition or subtraction before you undo your multiplication or division. So let's go ahead and take a look at some examples. As always, when we're doing our notes, you want to go ahead and pause the problem, try it on your own, and then log back in, replay the video when you're ready to check and see how you did. So for the first one, we've got 3x plus 4 is equal to 19. So we need to get rid of the 3 and we need to get rid of the 4. The first thing we want to get rid of is the 4. We always want to get rid of the thing that's farthest away from our x. So since the 4 is attached by addition, it's farther away from the x, which is right next to farther away than the 3, which is right next to the x. So to get rid of adding a 4, we're going to subtract a 4 on both sides. When we do that, the 4's cancel out. We're left with 3x is equal to 15. From there, then we need to get rid of the 3 next. 3 is attached to x with multiplication. The way we get rid of multiplication is using division. So we use our inverse operation, divide by 3. But remember, if we do it to one side, we have to do it to the other side. So the 3's cancel out on the left-hand side of the equation. We are left with x equals 5. As always, you want to go back and plug that number in and check and see if it works. So if we do 3 times the 5 that we just found for our x plus 4 equals 19, it should give us a true statement. If not, we know that we have done something wrong. So 3 times 5 is 15, plus the 4 is in fact 19. So it checks out. So we know our answer is x equals 5. All right, moving on to number 2. Again, pause the video at this point, try number 2, see if you can do it, and then turn it back on and see if you got it right. So we have 5z minus 13 equals negative 3. We need to get rid of the 5 and we need to get rid of the 13. We want to get rid of the 13 first because it's what's being attached by that addition or subtraction. So instead of subtracting the 13, we'll do the inverse operation. We will add a 13 to both sides. Subtracting a 13 and adding a 13 cancel each other out. So we're left with 5z is equal to negative 3 plus 13 gives us 10. From there, we need to get rid of the 5. The 5 is attached to the z by multiplication. The opposite of multiplication is, you got it, division. So we're going to divide both sides by 5. The 5's cancel each other out, so I am left with z is equal to 2. Again, we can go back, check that answer by plugging it back in. So we take our original equation, but instead of a z, we're going to put what we found z to be, which is 2. All right, so we have 5 times 2, which is 10, minus 13. 10 minus 13 is, in fact, negative 3. So we know that z is equal to 2 is our correct answer. All right, going on to our next one. This one has a little simplifying we want to do before we get our variable by itself. Z minus negative 9 is the same thing as z plus positive 9. So I'm going to change that into z plus 9. Makes the problem a little bit more simple. So now to get rid of adding a 9, we're going to use the inverse operation and subtract the 9. 17 minus 9 is 8, so we get z is equal to 8. We can plug that answer back in and make sure it works. So I get 17 is equal to 8 minus a negative 9. 8 minus a negative 9 is the same thing as 8 plus a positive 9, which is in fact 17. So we get z is equal to 8 for our answer. Remember, it's okay to write it as the 8 equals z that I have written here. Or we can write it the other way as z is equal to 8. It doesn't matter which one you have on which side. Okay, when we get to number 4, again, pause it, see if you can try it on your own first, and then check and see how you did. So we want to combine any like terms that we have first. 2 plus 4, they're both on the same side of the equation. That's something we can do. So we actually want to add 2 plus 4. From there, then, we want to get the d by itself. So we have 6 minus d is equal to our 15. So let's get rid of that 6 first because it's attached by the addition or subtraction. This one, we need to do 6 minus 6. 6 minus 6 cancels out, and it gives us 9. A common mistake here is that we are used to using the inverse operation. We see subtraction right here, and we think we need to use addition. But because the subtraction is on the d, not on the 6, that's why we are subtracting the 6. 6 minus 6 is what is going to cancel out. So we get d is equal to negative 9. 9 is equal to negative d. We're not done yet because d is not by itself. We still have a negative that's attached to our d. So we need to get rid of that negative. To get rid of that negative, a negative d is the same thing as a negative 1d. So now we have negative 1 times d. The opposite of multiplication is division. So we'll divide both sides by negative 9. And when I do that, I get d is equal to negative 9. Okay, dividing both sides by negative 1 gets rid of that negative, and it also makes sure that we have our variable by itself. Again, we can plug that back into the original equation to make sure that it actually works. So I have 15 is equal to 2 plus 4, which is 6, minus a negative 9 right here is the same thing as plus a positive 9, and 6 plus 9 is in fact 15. So it checks out. All right, as we get to number 5, we have f divided by 4 minus 5 equals negative 9. Again, we always want to get rid of that addition or subtraction first. So I'm going to start by adding a 5 to both sides. So I'm still left with f over 4, and it's equal to negative 9 plus 5 is negative 4. So now we have to get rid of our 4 that we are dividing by here. F over 4 means f divided by 4. Dividing by 4 can be undone by multiplying by 4. 4 divided by 4 cancels out and leaves us with just f, and then we need to multiply the other side by the 4. Remember, whatever we do to one side, we have to do to the other side of the equation. So negative 4 times 4 is negative 16. So we get f is equal to negative 16. Again, we can plug it back in and check our answer. So instead of an f, we're going to plug in a negative 16. And we're going to see if it does in fact work out. So we have negative 16 divided by 4. Negative 16 divided by 4 is negative 4. Negative 4 minus 5 is in fact negative 9. So it does check out. All right, go ahead and try number 6. Once you've got it, go ahead and unpause the video and check and see how you did. So on number 6, we've got q plus negative 5 and then divided by 3. This one's a little different. Normally we get rid of that addition and subtraction first. However, because the entire thing is being divided by 3, notice it's not just the q that's being divided by 3. The entire side is being divided by 3. So because of that, we want to get rid of dividing by 3 first. We're going to multiply by 3 on both sides, and it completely cancels that 3 out. So we are left with q plus a negative 5. And it's equal to 24. Now that we've gotten rid of that dividing by 3, we're down to that simple one-step problem to solve. To get rid of adding a negative 5, we're going to add a positive 5 to both sides because negative 5 plus 5 cancels each other out. So I'm left with q is equal to 29. Going back, checking our work, we can plug in a 29 where our q is and see if it does in fact work out. So we're going to take a look and we're going to do 29 divided by negative 5 first. When we do that, that gives us 24. And 24 divided by 3 is in fact 8. So it checks out, so we know that q is 29. Okay, when we get to number 7, we're going to start by using the distributive property. Distributive property says that whatever is being multiplied by on the outside of the parentheses has to be distributed to both things inside of the parentheses. Notice this part in here, out in front, the 12r isn't going to change. We're just going to keep it there. So I have 33 is equal to 12r. I won't change that part. But now I need to distribute the negative 3 times the 9. So negative 3 times 9 is a negative 27. And then I need to multiply the negative 3 times the negative r, which will give me a positive 3r. A negative times a negative is a positive. From this point, I have some like terms that I'm able to combine. 12r and 3r are like terms. They both have r's on them, so I'm going to add them together. So I have 33 is equal to 12r plus 3r is 15r, and I still have minus 27. Okay, so now I've used the distributive property. I've combined my like terms. Now I want to start getting my variable by itself. I always want to get rid of that addition or subtraction first. So I'm going to add that 27 over. 27 plus 33 is 60. So I have 60 is equal to 15r. To get rid of the 15 is attached by multiplication. So we're going to use division. We'll divide both sides by 15. 60 divided by 15 is 4, so I know that r is 4. Okay, again, we can go back, plug our answer in, but this time we actually have to plug our answer into the r here and to here to make sure that it does in fact work. So I am left with 33 is equal to 12 times my 4 minus 3 times 9 minus 4. So I get 33 is equal to 12 times 4 is 48. And then I use my distributive property, or I can simplify what's there. So I can write a negative 3 times, and then 9 minus 4 is 5. So I get 33 is equal to 48 minus 15, and 48 minus 15 is in fact 33. So I am left with that checking out for my answer. All right, we have one last problem. Go ahead and try this one. Pause the video, and then when you've got it finished, unpause the video and try it one more time. Make sure that you have got it. So we'll keep the 7 where it's at, but we're going to have to distribute that 3 through. So we'll have 7 plus, when we do 3 times 2g, that gives us 6g, minus, and then 3 times 6 will give us 18, still equal to negative 29. Okay. From there, we have some like terms we can combine. 7 and negative 18 can be combined. So when we add a 7 plus a negative 18, or if we think about 7 minus 18, either way, it gives us negative 11. We're left with plus our 6g, and it's still equal to our negative 29. So now we're trying to get our g by itself. We're going to undo that addition or subtraction first. So add the 11 to both sides. So I'm left with 6g is equal to, when I have a negative 29 plus 11, that gives me a negative 18. My next step is going to be to divide both of them by the 6. If I do it to one side, I have to do it to the other side. My 6's cancel out, and negative 18 divided by 6 is negative 3. So I get g is equal to negative 3. I always want to go back and check my answer so I can plug it back in, make sure it does in fact work. So I have 7 plus 3 times 2 times negative 3 minus 6 equals negative 29. So inside my parentheses, 2 times negative 3 is negative 6. Negative 6 minus 6 is negative 12. I'll bring everything else down. So then I'll do my multiplication next. 3 times negative 12 is negative 36. So I'll have 7 plus my negative 36, which does in fact equal negative 29. So it checks out. As always, when we finish our lesson for the day, you want to make sure and write down a summary. How would you explain to someone who missed this lesson how to solve a multi-step problem? Go back through your notes. If there were any of the problems that we worked that you had questions on, make sure and star them. If there's a type of problem that you think you really want to see more examples of, go ahead and make a note of that as well. And then tomorrow during class, you can make sure and ask questions on that to get all of your questions answered before we move on to the next section.